Good morning to all of you. I am Dr. THIRUVENKATASAMY, Professor and Head of the Department of Harbour and Ocean Engineering. Will be giving a lecture on dredging. As you all know, dredging is a process of removal of the subsoil in waterlogging areas, which will be used to deepen. It will be used so that the land will be used for storage of water, deepening of the water depth. So it can be a river dredging or a lake dredging or a ocean dredging. So it depends upon the location and the purpose. The dredging will have a various objectives. So if we see the topics for this lecture, it is a history of dredging, modern dredging, why we have to dredge, and how to do the training that. History, see in the olden days, this is a very simple primitive picture. So it shows how simple dredging occurs. A person is demonstrating. So in the olden days, dredging design, it started with Leonardo da Vinci. So here we can see the dredging pictures. So you can see it looks like a bucket. It rotates on a boat, and so that it will go down into the river or ocean, flux the soil. So this is a simple pictorial sketch. So these are the very olden method of dredging. So here we can see the hopper dredger. So how two wheels which has a ropes and it is clubbed to a bucket, so that by rotating the soil gets lifted. So this is another definition sketch. So these are the very olden method of dredging. So it will be stationed. See, a big wheel which has a bucket is rotated at a particular point, so that it will plug the soil. The dredged soil is removed. So this is another small vessel which is used to dredge in the corner of a waterlogging area, so that the front wheel will have a rotation. So this is also a type of bucket dredging. This is another dredging. So we can see the Panama Canal. So as you all know, the ships are designed by the term called the Panamax. So you know Panamax. Panamax is a depth of the Panama Canal. That is the maximum reference depth which is used to design the other ports and harbors all over the world, so that the vessel will access. So Panamax is the maximum depth at which the vessels are designed. That is, the ships will have a draft depth. So maximum draft depth is equal to of a ship is equal to the draft depth of the Panamax. That is the vessel which crosses the Panama Canal. So it is a reference depth. So the Panama Canal is how the dredging has been made in the olden years. So modern dredging has excavation, transportation, disposal or end use of the spoils, support equipment and training. So excavation, so we have to dig the soil. So that is excavation, then transport it to a particular place, then dispose it. So for that we may need a supporting equipment and a trained manpower. So this is a latest modern type of a bucket dredger, which is used in a port. Here we can see the bucket is getting down into the water, so which will go up to the seabed, plugs the soil, and it is removed and it is stored in the back side of the dredger. So this is a simple representation of the mechanical excavation. So bucket dredger. This mechanical dredgers. Mechanical dredgers are classified as clamshell dredge, backhoe dredge, bucket ladder dredge, dipper dredge, dragline dredge. So once again repeat. The mechanical dredgers are classified as clamshell dredgers, backhoe dredgers, bucket ladder dredgers, deeper dredgers, drag line. So we can see the clamshell bucket dredgers. So this is it looks like a clamshell dredge. So the name is named after this, the shape of the bucket. So this is one of the latest and frequently used dredger. And this is a backhoe dredgers. So this is similar to a clamp. It lifts it and bring back to the nearby barge. Bucket ladder dredger. This is also one of the traditional dredging which is used where there is a necessity of extensive volume of the subsoil in a ocean, or it can be a river, or it can be a lake also. So the dredger is positioned at a particular depth for several hours or weeks. So the bucket ladder, the buckets are fixed on a ladder, so which is rotated using a centralized wheel system and equipment. So once it goes down and it picks the soil and it comes up and it is poured into the pipe and it is collected in the hopper. So this is a bucket ladder dredge. So this is a deeper dredger. So deeper dredger is also similar to bucket dredger, but here it goes up to the total bottom and it plugs, which the dredge clamshell will have a long panel which will plugs the soil more wider width. So we call it as a deeper dredger. Then hydraulic excavation, using the hydraulic system. As you all know, this hydraulic efficiency of the oil. So using the hydraulic system, it plugs it and it comes up. This is a hydraulic excavation. So hydraulic dredgers, it can also be classified as cutter section, dust pan, plane section, water injection dredgers, hopper dredgers. I repeat once again, cutter section dredgers, dust pan, plane section, water injection dredger, hopper dredgers. So here it is a very important point to note that why we have so many type of dredgers. The dredgers are useful and dredgers are used for a specific purpose. It depends upon the volume of dredging. It depends upon the type of the sediment, depends upon the condition of the seabed or the riverbed, whatever may be, and depends upon the flow, depends upon the water flow. So the cutter section dredgers are used exclusively where the soil will have a rocky base. The seabed is with a rocky base, the cutter section dredgers are used. Dust pan is also used where we have a colloidal substances. Then plane section dredgers, then water injection dredgers, hopper dredgers. Plane section dredgers are where the liquid material is enormous, we can sub that. Then water injection dredgers. This will be very useful where mixture of a rocky phase as well as the soil interface. When there is a rocky interface with the sedis collider, so if you want to lift that rock, we may inject the water in between the gaps so that the rock mass will get solidified, will get loosened, and then it can be removed through the hydraulic. Hopper dredgers also the similar to that. So cutter section dredgers, here we can see the dredger will have a cutter section which has a lot of tools, which is a very sharp equipment. So when it is grinded on the seabed, in the rocky bed, the rocks get crushed. Then parallelly it can be removed. So that is a cutter section dredgers. Water injection dredgers. This is a water injection dredgers. Then dust pan dredgers. Dust pan dredgers where there is a water with colloidal soil mass, it can be removed using the dust pan dredgers. Trailing on hopper dredgers. So trailing on hopper dredgers, we can see that it is sucked from there and it is sucked through the pipe and it is placed it and then it is removed. So here we can see the hopper section. So it is removed from there, from the ocean, and then it is stored here and then it is removed through, it is sucked through to the nearby location. Then the transportation of dredgers. dredged material. So once as I said earlier, the suction dredgers, once it is any dredging material, once it is excavated, then it is stored in the parts of a dredger, or it can be a nearby barge, it is stored. Then the next point is the transportation of the dredged material. There are so many practical problems which we will face in the transportation of the dredged material. One point is the underwater current. Another is the condition of the dredged sediments. Both plays a major role in transportation. So it depends upon the speed of the underwater current and depends upon the quantity and type of the sediment size which is dredged. The transportation will have a different way of approaches. For example, so here the dredged material is transported through the pipes, and here it is made as a separate item so that it is classified, it is separated from the other open area. So here also it is transported through the barge. Then barge or a pipeline. So there are two aspects in shifting the dredged material, that is in transporting the dredged material. So the dredged material, it is transported from one place to another place, depends upon the convenience and depends upon the condition. So here we can see it can be transported through the pipeline. So the dredged material is removed from the ocean and then it is transported from the deep ocean to the land by flexible pipe, and then it is linked with the standard pipe, then it is dredged. It is stored in a trench. And this is, you can see this dredged material stored in a barge. The barge is towed through a small crafts. So this is another barge empty which is ready to get filled with the dredged material. And this barge is filled with dredged material. It is full. So this is a barge system of transportation. The disposal of spoil. So the disposal of dredged material is another one important point which we have to consider in the dredging process. This is because the dredged material will have an adverse effect on the environment. For example, if we dispose the dredged material in the ocean surface, the nearby fauna and flora, it should not get disturbed, because the fauna and flora will be in the benthic layer. So many fauna and flora will need sunlight for their growth. So if the dredged material is dumped at a place, so that will create a turbidity. So that will obstruct the sunlight. So that will affect the growth of the flora and fauna. So the location, identification of the location for disposal of spoils, the dredged material is called spoils. That is most important. It depends upon the quality and quantity of spoils. The dredging disposal will differ. For example, it can be removed and it can be plugged and it can be disposed in a nearby land area. If it is in the deep ocean, then it may be disposed at a remote place where the very deep trench occurs. There it can be disposed. So this, in order to identify the disposal of spoils, one has to go for an extensive bathymetric survey. So the bathymetric survey will give a clear picture on the location of the humps and valleys below the seabed. This is a barge unloader. So this is how it is dredged material. It is put it in the, now we can see this barge unloading. It is unloaded and it is transported to the pipe, and it will be disposed in the land at a suitable place where it will not make any environmental effect. Support equipment. So in order to do the dredging, the following are the supporting equipment: drill rig, survey boats, stiff legs, drag barges, boosters. So drill rig is used at a point where we have to grind the road. We have to make a deep depth in the seabed. Survey boats, in order to make a subsurface like a bathymetric, and stiff legs, drag barges, boosters are the supporting equipment. So here we can see the rig and and this is a void, and this is also a ring. Boosters. These are the boosters which we can, which will be used to shift the transported material and where it can be stored and at a particular point, and from there it can be used as a control station to do the dredging in the nearby area. So why do we dredge? What is the purpose of the dredging? So channel deepening and maintenance. Channel deepening and maintenance, which is a very, very important aspect in port development. So when we develop a port, depends upon the location. When we develop a port, depends upon the location, the seabed will differ, seabed depth will differ. So in order to make a convenient way to approach the vessels into the water, from the ocean into the harbor, the navigation channel is to be dredged. The navigation channel will have several meters of width and depth, and so many, nearly about more than a kilometer of length from the ocean, harbor to the ocean. So the navigation channel, it should have a clear-cut dimensions so that the channel will not have any sediment accumulation, so that the vessel will have a very convenient way of approach towards the ocean, so that we need the required draft can be maintained. So navigation channel, design of navigation channel, especially the dredging aspect, is a very, very important one, where we need a maintenance also. We have to maintain that sidewalls depth and slope. The reclamation of land, that is used for the coastal restoration projects. Then beach nourishment and restoration, mining for aggregates and minerals. So mining for aggregates and minerals, it can occur even in the ocean, or it can be on the river, or it can be on the lake also. So based on the purpose, the dredging will differ, dredging equipment also will differ. So then next is maintenance dredging. As we all know, once the port is developed, the maintenance dredging plays a major role, because maintenance dredging is to be the depth of the harbor region as well as the navigation channel is to be maintained with the particular depth, so that the vessels can move freely and make the most efficient operation of the port. Because when the vessel moves, and due to the monsoon and the ocean, various ocean phenomena, underwater currents and storm surges, the sediment deposition and accretion will occur at various locations of the harbor, inside and outside the harbor. So in order to maintain the depth, maintain the draft of the vessels, this maintenance dredging is very, very important. Then similarly the reclamation and land use. Then beach building and mining. So beach tourism is a very, very important one, where the revenue is generated for any country. So the beach width, what is the beach width, how the slopes will be maintained, the nearby area. So in order to develop the beach front area, this dredging is needed. Then aggregate mining. Aggregate mining is used to develop the aggregates for building purposes. Here also the dredgers are used. The training. So once dredging is set an objective, the most important point, one of the most important point is we should have a trained manpower. Trained manpower, skilled manpower and qualified personnel are essentially needed. That is, harbor personnel are Coast Guard, licensed, DSMP training, on-job training, union schools, and safety, coastal safety. These are the trainings that to be given. And survey is one of the important one, so that we can see before starting any dredging project, the first foremost one of the important point is we have to make a survey of the region. So then only we can, what is the total area we have to survey, what is the total volume, how much volume of dredging material, how much volume will come. This will evaluate the time of dredging, project management as well as the cost of the dredging. So that is dredging track. By using the periodical bathymetric survey, the area can be evaluated and ups and downs of the seabed can be identified, so that the dredging can be most efficient and cost benefited. So survey is very, very important. Thank you.